water, especially
Calculation.
here.
Which calculation is that?
All these gas of kinikon, they now give us
Eh?
an equation, like a gas giving us an equation and telling us to find the volume of the air.
No, that is under stoichiometry. That means you mix some stoichiometry question with it. We have treated
Okay.
stoichiometry. That is stoichiometry. You still remember stoichiometry?
Yes,
The
yes,
only
yes.
calculation
Yes.
I think you can have under soil and water, aside stoichiometry, is hard water and soft water. But I don't think we have to do the calculation. But now you will see it in some of these 1980 questions. But the recent one, you will not see. There's calculation on the volume of soap that you will need to remove the hardness of water. Maybe I will still revisit that. Maybe you will do the calculation parts. But it's not part of, I don't think it's part of the JAMB syllabus, the calculation part. So any calculation that you see is likely stoichiometric calculation. And we have treated stoichiometry. So if they're asking you for volume, maybe mole and volume, remember this formula, that long formula we did then. We're actually going to revisit that formula. N equals to mass over molar mass. Mass over molar mass. Which other one? Number of moles, number of particles over Avogadro's number. Then what again? For gas, volume over what? 22.4.
1,000.
Abi? Then
Yes,
what
sir.
again? Concentration times volume. We are still going to add, I think, one more to this. When we get to electrolysis, I will add one more to it. There are also an equation under electrolysis that will link with this. So if they're asking you volume, so it's likely if it's a solution, you are using this. If it's a gas, you are using this. Then you are relating to the one you are given. This is mole. So this is the mass. This is for number of particles. This is for volume of gas. This is for solution. This for solution. So depending on which one you are being asked, if its question is on mass and concentration, so you are picking this and this. If the question is on mole and volume of gas, you are picking this and this. If the question is on mass and number of particles, you pick this and this. Do you get that? So can you remember any of the question? Just to show you that they are stoichiometric questions.
I can't. Should I read it out?
Okay, yeah.
Okay. I'm coming up.
I can hear you. Can you read it out now?
Okay, sir. I'm coming because we treated. Okay. I want to look for the question. Okay. Are you with us?
I'm with you.
Okay. So the question says, it says 10 dm cube of air containing H2S as an impurity was passed through a solution of PbNO32 until all the H2S are reacted. Now says the precipitate of PBS was found to weigh 5.02 gram according to the equation. So we're given PbNO32 plus H2S, the plus PBS, the plus 2NO3. He said the percentage by volume of hydrogen sulfide in the air is. So we're given.
And that is stoichiometry. That's what I'm saying. Okay, the question again.
Yes, sir. He said 10 dm cube of air containing H2S as an impurity was passed through a solution. Yes,
10 dm cube of air containing H2S.
Yes, sir.
Right? So the air is,
yes, sir.
The volume of the air is 10 dm cube and it's containing H2S, right?
Yes, sir. He said was passed through a solution of PbNO32.
Okay, you pass H2S.
All the H2S
has reacted, right?
Yes, sir.
Okay,
the precipitate So the precipitate of PBS was found to weigh 5.02 gram.
I'm coming. PBS that was formed 5.02, right?
Yes, sir. Gram.
Okay. Plus.
Then according to the equation.
Plus.
Yes, sir.
HNO3, right? PBS plus HNO3.
No, we have PbNO3 plus.
And I've written it on the board. Is it what I wrote on the board?
Let me check, sir. Yes, sir. It is.
So this one was formed, right? Okay.
Sir?
Is that all? I said
yes, sir.
5.02 gram of PBS.
The percentage by volume of hydrogen sulfide in the air is. So that's the questions.
Okay, the percentage of hydrogen sulfide that is in the air. That's what you have to find.
Yes, sir.
So it's
yes,
a symmetric question.
By volume.
Yeah, I get you. So what you just do here is this. You obtain the volume of H2S that will produce 5.02 gram of PBS according to the equation. If you look at the equation, you are dealing with H2S and PBS. So according to the equation, 1 mole of H2S gives us 1 mole of H2S gives us 1 mole of PBS according to the equation. Right? Now let's convert it to mass.
Sir.
What would be the mass of 1 mole of H2S?
X.
The molar mass now.
That's 34.
34. So this is 34 gram of H2S. Will give us what now? 5 point what? We give us for PBS will be what? 207 plus 32, have it?
239.
239 gram. Then we are looking for the mass of H2S that will give us 5.02, isn't it? Isn't it?
Yes, sir.
We are looking for the mass of H2S that will give us 5.02 gram of PBS. So when you cross, what do you have? What will be the value of X if you solve this?
Zero point 714. 0.714.
0.714, right?
Yes, sir.
714 gram of H2S. So can we convert it to mole? How many mole of H2S is this? How many mole is this? That is 0.714 divided by 34. I hope you get that mass over molar mass. What do you say?
0.021.
So the mole is 0.021 mole. So this is the mole of H2S that reacted with the PbNO3. I believe you get that.
Yes, sir.
H2S is a gas, so we convert it to volume. We know that 1 mole of a gas at SCP has a volume of what?
22.4.
22.4.
So what volume of H2S will be produced by what mole? 0.021, right? So 0.021 mole of H2S will give us what volume now? That will be 0.021 times 22.4.
0.47.
0.47.
0.47. So this is the volume of, so that means the volume of H2S that is in the air is 0.47 dm³. So you convert this to percentage. So what will be the percentage of H2S in the air now? The percentage of H2S in the air will now be is 0.47 divided by what's the volume of the air?
That's 10.
10. You are given 10 initially, right? Then times
Yes,
100%.
sir.
Times 100%. So what would this give us?
4.7.
So that is, so the percentage of H2S in the air will now be 4.7%.
Yes,
Do
sir.
you get that?
4.7.
Yeah.
Yes, sir.
So is stoichiometry. Do you get that? They are only linking it with what you learned in air. So you are still using your stoichiometry.
Okay,
Do you
thank
get
you,
that?
sir. Yes, sir.
So you are still this is your formula still remain. This is what you will still fall back to. So depending on what you are relating, do you get it? I think we did
Yes.
for
Yes, sir.
composition, we did for reaction. For reaction, you will have to write the balanced chemical equation first. So it is from the balanced chemical equation that you pick the reagent or the species you are dealing with, the known and the unknown. So you use the known to calculate for the unknown. So you can use the mass, you can use the mole, then you can now convert to volume, which I did it because it has the percentage per by volume. So that was why I converted to volume. Assuming it's percentage by mass, we'll have stopped in mass. Do you get that?
Yes, sir.
So it's stoichiometry. So you may need to go and visit your stoichiometry. So it's not on air and gas. They're only trying to put in air and gas into the question. I believe you get that. Now, yesterday we started with solubility, right? We started with
Yes.
solution. We said a solution is a homogeneous
Yes,
mixture
sir.
of a solid and a solvent, right? So we said the solute dissolves in the solvent, while the solvent dissolves the solute. So we said the solute could be any of the three states of matter, could be solid, liquid, or gas, and the solvent could be a liquid, solid, or gas, but most times liquids. So a solution comprises of solute and solvent. So we look at different solutions, the solvent and the solute for different solutions. Different solutions. So we look at some of these yesterday. Then we talk about different type of solution. True solution, which is called solution itself. Then false solution, which is called collider solution. So false solution is collider solution. Now here, let me say this, lest I forget. Now, we said collider solution is false solution. Are you with me? So in a collider
Yes, sir.
solution, we do not have solute and solvent. So instead of solute and solvent in collider solution, we use dispersed phase and dispersed medium. So the dispersed phase is like the solute for a true solution. So the dispersed phase is like a solute for a solution. Then the dispersed medium is like the solvent for a true solution. Do you get that? So under collider solution, we don't talk about solute and solvent. We rather talk about dispersed phase and dispersed medium. Do you get it?
Yes, sir.
So the dispersed phase is like solid, the one that will dissolve in the solvent, like in solution. So the dispersed phase is like the solute for solution, and the dispersed medium is like solvent for solution. Do you get that? So we don't use solute and solvent. That's what I'm trying to say. For collider solution, we rather use dispersed phase and dispersed medium because we might come across that. I believe you get that.
Yes, sir.
Then for suspension, we said the particles are large. So we talk about some of their properties. Particle size, we said suspension, they have the largest particle size. Visibility, we said through solution and colors, they are not visible to the eye. But suspension, they are big enough to be visible. We talk about ability to pass through filter paper. Suspension can pass through filter paper. So we can use filter paper to separate the component of a suspension, but collider solution and through solution cannot. Then we talk about ability to pass through membrane. What do I call the property for the separation by membrane? I gave us the name yesterday. What do I call that? Can anybody remind us that the
Then
ability of the particles to pass through membrane? What do you call that?
Sir, it's dialysis. Dialysis.
Yeah, dialysis. So suspension can be what? Suspension cannot be dialyzed. The particles cannot pass through the membrane. Colloidal solution cannot be dialyzed. The particles cannot pass through membrane. But true solution can be dialyzed. The particles can pass through membrane. Then diffusion. So we said suspension slow, do not diffuse. Collider very slow. True solution very fast. Then settling. Suspension settle. Collider solution they do not settle. True solution they do not settle. Then nature heterogeneous, homogeneous. Tinder effect. What does the Tinder effect is?
Ability to scatter light. Scatter light.
Yeah, ability of the particles to scatter light. So which one has the ability to scatter light?
True solution.
Right? Suspension and collider, no, that can scatter lights.
Colloids and
Suspension and
suspension.
collider solution, they can scatter lights because of their large particle size. But true solution, because of its small particle size, it cannot scatter light. The light will pass through it. Do you get that? Then we talk about issues of solvents. Petrol, kerosene, ammonia solution to remove fat, oil, grease stain. Paint can be removed by turpentine. Solution of borax in water can be used to remove coffee and stain. And the rest. Then with this solubility, I think this was where we stopped yesterday. So solubility is the amount of a solute that can dissolve in a certain volume of a solvent at a given temperature. So solubility is temperature dependent. So the solubility of a substance in a solvent is temperature dependent. A substance that is insoluble at a given temperature, if the temperature is increased, can become soluble. If the temperature is increased. So I told us that we can calculate solubility in two ways. You can calculate solubility in either gram per dm cube or in mole per dm cube. So in gram per dm cube, you do mass of the saturated solution times 1000 divided by equal volume. I omitted volume here. Equal volume of water. So the volume of water, I said it can be in gram or cm cube. And that's because 1 gram of water is the same thing as 1 cm cube of water. So the volume of the gas, they can give you in grams. So if they give you in gram, no need for any conversion. Just use it directly. So 1 gram is the same thing as 1 cm cube. So 20 gram is the same thing as 20 cm cube for water. Then solubility in mole per dm cube, you just include molar mass. You include molar mass of the salt in the equation. So you do mass times 1000 divided by molar mass of the salt times equal volume of water in gram or cm cube. I think we solved a question on that yesterday. Now, this is another question on it. So 10 cm cube of saturated solution of sodium chloride at 30 degrees Celsius. Remember, it's not that you need the temperature to solve the question. You don't need the temperature in the calculation. The use of the temperature is just to tell you that the solubility of the substance is temperature dependent. A substance that can dissolve maybe 2 grams at 30 degrees Celsius, at 50 degrees Celsius, it will not be 2 grams again. So that's why we are quoting the temperature. So the solubility of a substance differs with temperature. Do you get that? It's not a constant with temperature. So as temperature changes, the solubility will change. So calculate the solubility of the salt. Number 1 in gram per dm cube. Number 2 in mole per dm cube. Our salt here is sodium chloride. So the chemical formula for sodium chloride is NaCl. NaCl. So we calculate the molar mass. Sodium is 23. Chlorine is 35.5. So the molar mass will give us 58.5 gram per mole. I believe there is nobody here that cannot calculate molar mass. Anyone like that? So please, if you don't know how to calculate molar mass, you need to work on that, please. So the molar
All right,
mass
sir. I'll work on that.
because
I'll work on that, sir.
I don't know how to calculate too.
what is it?
I don't know how
Sir,
to.
I'll work on that
You don't know
because
how to
I don't know.
calculate molar mass. We have been using, I don't think there is any
Yes,
class we had that we didn't refer to molar mass in what we have been doing. All the topics we have covered, I don't think there was any topic with it. The molar mass, you just get the relative atomic mass and add them up based on the formula. Sodium is, for this one, sodium is 23, chlorine is 35.5, and each of them one atom. So 23 plus 35.5 will give us 58.5. I might not be showing the calculation here. You can say I just wrote the answer because I believe by now everybody should be familiar with that.
I'll go and learn it better.
It's something you cannot escape in chemistry, please. Then we are to calculate the solubility in gram per dm cube. In gram per dm cube, the formula is the mass times 1000 divided by volume. So the mass of the salt is 3.9. That is 3.9 times 1000 divided by the volume of water that was used is 10 cm cube. So divided by 10 cm cube, we are going to have 390 gram per dm cube. Then in mole per dm cube, solubility is mass times 1000 divided by molar mass times volume. So the mass is 3.9 times 1000. The molar mass of the salt is 58.5. Then volume times 10. So when you solve this math, you have 6.667 mole per dm cube. So those are the two ways solubility can be found. Then another way is this. They can ask to calculate solubility per certain gram. For example, they can say you should calculate the solubility of a particle or of a solid per